Okay, good afternoon. Who here has been to Dan Bodar's Crazy Fast Build Times talk? Oh, so few people. Actually, this talk is like a prequel to his talk, so. Okay, good afternoon, everyone. That's my younger self. That's me over 7 years ago, starting my professional Java career, so to speak. Very, very anxious. If you're wondering what I knew at the time, here's my fairly basic technology stack. Java, JSP, servlets. Nothing really fancy. By the way, please know how proud I was of my certificates. I was actually so proud of them that I even put like a Sun-certified Java programmer watermark on my resume. How cool I am. In retrospect, I have to say that I was very, very naive at the time. Very naive, but also very hungry for knowledge. And I was asking many questions, like this one on Java Ranch. Basically, I was asking, hey guys, I'm trying to build a web app. Please help me. I've been thinking of those three technologies, Struts1, Struts2, and Spring MVC. Which one should I choose? And things that I care about are like a flat learning curve, and I want to have available materials like books, tutorials about this particular technology. So one good thing about my younger self is that I knew that MVC is good. 1 point for my younger self. I also had my values. I wanted things to be easy and familiar. And here are some of the answers that I got. Spring MVC is pretty nice, yada, yada, yada. But I also got very brief answers, like, I really like stripes. Very, very nonchalant. It was like, I really like stripes. But this guy did a brilliant job, because I was suffering from what psychologists call a narrow framing. I was artificially limiting my options by saying, oh, I want to choose from A, B, and C. And the guy said, try D. Very, very nonchalant. But I didn't listen. And eventually, I went for Struts1. You may ask, why? Well, because there was this book about Struts1 on Amazon, and it had so many good reviews, they just couldn't resist it. So thank you, Amazon, for recommending Struts1 to me. Why am I telling you this story? Many things we're going to talk about today, they don't have great documentation. There are no shiny books written about them. Some of them may not be easy or familiar to you, but they will definitely be super, super simple, and they make me more effective than anything I've seen up to date in the Java space. So when I was younger, I didn't have many options. But now, with more experience, I have the opposite problem. I have too many options. And here's what psychologists have to say about too many options. Increased choice may actually contribute to the recent epidemic of clinical depression affecting much of the Western world. So, too much choice, depression. And I was depressed, being constantly bombarded with all those new web frameworks every single day. So over time, I came up with my web framework litmus test. What's like one question I can ask myself to quickly separate the wheat from the chaff. And here's the question. Does my web library hide HTTP from me? If it does, then I can ignore it. If it doesn't, then it may be useful. 7 years ago, I would give a fortune to hear just this one statement. Your web library should not try to hide HTTP from you. I would be able to discard all those stateful component web frameworks that were trying to give me like additional layer of abstraction on the top of something that's a perfectly fine layer of abstraction. My mantra as of today is be off the web, not just on the web. Your web library should have things like status codes, HTTP headers, common web programming idioms as first-class citizens. Now, if you want to find a really nice web library, try this experiment. After this conference, go back home, go back to your office, find a request object in your favorite web library, and invoke a toString method on it. and see what it gives you. Is it some gibberish like that? Or is it actually a nice on-the-wire representation of your HTTP request? Chrome DevTools tells me everything about my request in the browser. Why shouldn't I expect the same thing from a toString method on the server side without writing any additional code? And finally, I'll tell my younger self to learn HTML, CSS, and JavaScript properly. For a very, very long time, I resisted learning them. And I was thinking, oh, I'm a Java developer. I want to write all my code in Java. And JavaScript can be generated. But this is a short-term thinking. HTML, CSS, and JavaScript are not ideal, but they are much better than anything I've seen in that space. The second most important thing, in my opinion, when choosing a web library is to pick a right concurrency model. So most Java developers are familiar with a thread per request model. So basically, you have like a thread pool, your request arrives, you get this thread, you invoke your business logic on this thread, then you go to a database, and your thread waits for you like a faithful dog. Then the data comes back, you spit it out to the browser. This model is very easy to reason about. But I remember that back in 2009, this Node.js thing became extremely popular. And people were raving about non-blocking I/O, event-driven systems, and I was confused. I was like, what should I do with all my existing Java apps? Should I start rewriting all of them? But then I started digging deeper, and I realized, well, it's not really that new, because I already know those concepts from the browser. So I was already registering those different events in the browser, and I was assigning different callbacks to them. And I knew that there is this thing called single-threaded event loop in a browser. And if there's some event happening, like mouse-click event, well, there's appropriate callback invoked. And if there's like another event happening, like data arrived from a server, another callback is invoked. And if there are like multiple events happening, well, they're just put in a queue. And one after another is handled on the single-threaded event loop. It turns out that Node.js is exactly the same thing, but on the server side. And yes, you have to learn some new APIs to handle non-blocking I/O when you talk to your database, for example, but the entire conceptual model is exactly the same. Now, my younger self would ask me, so which one should I choose? In practice, which one should I choose? So here's my advice. If your application is doing like lots of I/O orchestration, so let's say you get a request, but then you have to make 3 external calls to 3 external web services. Wait for them. Then you have to go to your own database, get the data back, put it together, go to another web service. Well, then probably something like Node.js is a fit for purpose. But on the other hand, if you try to do something like a number crunching or a huge XML transformation on the single-threaded event loop, that's not a good tool. Number 3, dependency injection. So the previous 2 items were pretty much common sense. But now we're stepping onto a dangerous ground, because every Java developer that I know has a very strong opinion about dependency injection. So when I was younger, I just assumed that when you start a new Java project, you have to put something like a Spring jar on your class path, because it will be needed, right? It will be needed. Imagine my surprise when several years later, I discovered that actually the IOC containers are optional, and it's all about argument passing. And I remember reading this book back in 2009 called Growing Object-Oriented Software Guided by Tests, where 2 authors test drive their entire application without using any DI containers or IOC containers. And it was like a game changer for me, because I realized that you can basically just take a new operator, move it up the stack, and you're going to have this entry point to your application where you put things together. And it's that simple. But then I started thinking, maybe those 2 authors are the only 2 people who do it that way. So I started digging deeper. And I found this reply from Joel Spolsky of the Stack Overflow fame. And he says, if you use IOC containers, your code becomes, frankly, a lot harder to read. And if it was like some random dude saying that on Stack Overflow, that would be a public lynch. But hey, this is Joel Spolsky saying that. So there are very successful people who don't use any IOC containers in their code, and they are perfectly fine with that. But then I started digging even deeper and asking myself those questions. Are there any contexts where DI containers may be actually useful? And I found at least 2 good use cases. So imagine you have like this massive code base, okay? Like 1 million lines of code. and there's like a new person joining your project. And they have to work in this big monolith somehow. And you want them to get up and running very, very quickly. Well, there's no time for them to learn everything. So you're gonna tell them, okay, you're gonna create your new service here, and you're gonna declare those 3 dependencies on those 3 services that we're gonna provide to you, okay? Don't worry about anything else. Those 3 will be injected. And it's a fair use case. Not everyone's doing microservices. Now, a second good use case is when you actually write your own library or a tool. Because then you don't know at compile time what classes will be needed. So this is like a good injection point for your library. But when you write your own code, your own web application, you know at compile time what you're gonna need. So, of course, no talk would be complete without a mention of a DI tool. So I'm gonna tell you about my favorite one. But before that, I want to tell you a story of a guy whose name is Kobi Kobayashi. Kobi Kobayashi is a hot dog eating contestant. If you're wondering what hot dog eating contests are about, it's basically you have 12 minutes. And in those 12 minutes, you have to eat as many hot dogs as you can. And actually, here's the thing. Kobi is like a regular guy. He's not like all those massive dudes who participate in those contests. So he had to be smart. So he was observing how other people eat hot dogs. And he realized, well, most people just eat their hot dogs the way you would do on a Sunday barbecue, but just 10 times faster. So they were basically cramming all the food into their mouth. But he was smart. He realized, oh, if I separate the hot dog from the bun, and I eat them separately, I can eat 2 times faster. So this separation, hot dog from the bun, was essential. And here's the question, how this weird metaphor leads us to my epiphany about DI containers. So number 1 reason why I find it so difficult to reason about things like Spring is, or other mainstream containers, is that they conflate 2 things. They conflate object wiring with scope. But here's the thing, Java already has a scope. Java has objects, so instance variable in an object can define a scope. And Java has methods and blocks, and this is another scope. So for me, the key is the separation, wiring from the scope. And I'm gonna explain in a second what I mean by that. And I'm gonna use Yadik, yet another dependency injection container, as an example. By the way, the author of Yadik is sitting here in the first row, so. Here is how Yadik works. Basically, everything is done in Java code. You instantiate your container like that, new simple container. Then you can add stuff to your container. And Yadik is basically a type map. So you specify some key being your interface and a value being your implementation. You can decorate stuff. So things you'd normally do in aspects, you can do also in decorators, which are much easier to reason about. So you can express all your cross-cutting concerns as decorators. And then you can get stuff from the container, and you get like a fully auto-wired object. Now, you might ask a question, but where's my request scope? Where's my application scope? Well, I don't think those are part of your DI containers domain, because they are part of the web applications domain. So let's see how we can model a web application using Yadik. So we're gonna have a class that represents our web application. And if we need some application scope, well, we're just gonna create one container as an instance field. Now, here's the thing. Almost every web application out there has some kind of a handle method that's invoked on every single request. And it takes like a request object and can give you a response back. What if we create another container inside this method? It's automatically scoped to this block of code. And it can have a reference to the application scope. And now we modeled everything that we need. So I want you to ask yourself a question. When choosing a DI framework, DI library, what do you prefer, simplicity over features? Some people may say, oh, if I see a class that's called Transaction-Aware Persistence Manager Factory Proxy, it's a sign of good design, because there's like half of gang of 4 patterns in this name. But for other people, it may be actually a sign of over-engineering, and the reason why some libraries should stop taking drugs. I'm still seeing those projects where people have those huge XML configurations for their DI tool. And if you use XML for things like that, you have to ask yourself a question. Do you really need to switch those XML files in production? Because maybe you do. Or maybe you deploy a new version of your application and you don't need this XML? Does the XML parsing time bother you? That you spend like 3, 4, 5, or even more seconds parsing your XML config? Does it bother you that you need a special tool that understands that, oh, this XML code and Java code are somehow related? Do you need a special tool for that? But some people say, no, no, we use annotations, right? And yeah, I'm seeing those code bases where you have those add autowire or add inject annotations spread all over the code base. And some people say, no, it's fine. But some other people may say, no, those annotations are like dandruff for Java. It's not going to kill you, but it's not very aesthetically pleasing. Next story. Some time ago, I was reading this book by Malcolm Gladwell called David and Goliath. And this book is basically a case study of underdogs actually battling and beating the giants. And the #1 takeaway message from this book is that when you're this tiny guy, David, with a slingshot, you don't fight with Goliath, the huge guy, by playing to his rules. You have to redefine the rules of the game. That's how you win. And this weird metaphor, another weird metaphor, brings us to the topic of the web servers, aka the powerful and the strong are not always what they seem to be. I have to say that nothing makes me more happy when I can join a new project and I can just go to the version control system, check out everything, find a main class, find a main method, and just run it. Nothing else. Main-driven development in its purest form. This code is beautiful. There's like a new instance of a server that takes my application as a first argument and some configuration as a second argument. I can reason about this code. I can step inside this code with my debugger. Those embedded web servers are becoming increasingly popular nowadays. And there's a very good reason for that. The first very good reason is that they give you this dev prod parity. My code runs exactly the same way on my development machine and in production. And there are no discrepancies, no extra jars in production. And the second very good reason is that startup times for things like JDK server, simple framework, or embedded Jetty, they are measured in milliseconds. So Dan was talking about it. When you start using those, you can run your functional tests as part of your commit build. The traditional advice that, oh, you should run your functional tests sometime later in your deployment pipeline becomes irrelevant because you can run all your tests straight away. Of course, there's no free lunch. There are always some trade-offs. So first thing is you have to let go of the admin consoles. So if you love to deploy your war files to Tomcat with the admin console, you have to forget about this. But you shouldn't use it anyway. And yeah, you're going to use more memory because now you're going to be spinning up those Java processes in production. But hey, it's 2014. Memory is cheap. And you have to learn how to automate stuff. So, but again, it's 2014. Continuous delivery is not some kind of magic art anymore. #5, template engines. So now we're going to talk about libraries that generate HTML on the server side. So I know that everyone agrees that logic view separation is good, right? Everyone agrees. Developers can work on their code. Designers can work on the templates. Everyone is happy. Everyone agrees. Not everyone practices. It's one of those cases where common sense is not common practice. I remember when I was younger, I was just assuming, OK, when I'm going to choose a template engine, I'm going to pick the one with the biggest number of features, right? More green boxes. But not all those green boxes are features. Some of them are traps. I was reading this book by the Heath brothers some time ago. This is actually a very good book about introducing any kind of change. And one of the change patterns that they describe is called shape the path. If you want people to do the right thing, make it easy for them to do the right thing. And make it really difficult for them to do the wrong thing. And it actually brings us to the topic of the logicless templates. So your template engine should give you just enough power so that you can express very basic view logic, but it shouldn't give you enough power so that you shoot yourself in the foot. And if you're wondering where to start, there's a nice paper by this guy whose name is Terence Parr, he's the Antler guy, where he describes what's like the minimal set of features that your template engine should give you so that you don't shoot yourself in the foot. And if you ask me for some names of the tools that you can use starting tomorrow, I'm a big fan of the Mustache family. I've been using things like Mustache and Handlebars myself in the Node.js space, but I know that there are Java ports available too. And also, please make sure that whatever template engine you choose, that is testable, that you can just instantiate it, pass some arguments, get the data back with no dependencies on a container, for example. Your template engine should be testable too. Number 6, logging. How to keep logging simple. One of the most valuable links I've seen this year is this 12-factor app. Has anyone seen that? Okay, 3 people. You should check this out. Basically, it's like a manifesto created by one of the Heroku co-founders, Adam Wiggins, and he was basically observing like hundreds of apps running in production. And he found those reoccurring patterns that make apps scalable, portable, and basically a joy to work with. And here's what he has to say about logging. Treat logs like event streams. What does it mean? So most people have a very bad conceptual model of logging. People think logs are files, which is a really, really bad model. Much better model is that logs are just time-ordered streams of events. Now, what does it mean in practice? In practice, it means that your Java application should only write to standard output and standard error. And you should let your operating system do what it's really good at. So, for example, instead of using something like file appender, well, use redirect. Instead of using something like a rolling file appender, you can use log rotate. Now, if you use something like a syslog appender, well, use a pipe. And if you need to do both, if you need to write to a file and to a syslog, use the T command. The moment you start writing to a file, directly to a file from your Java application, you lose the power of Unix streams. So yeah, it's all about the Unix philosophy. Let your Java applications do what they're really good at, which is handling some business logic, but not logging. But also make your apps composable. Expect the output of every program, even Java program, to become the input to another as yet unknown program. Because the next guy is only one pipe away from you. Pragmatic Web Testing. So many people use tools like Selenium or Jab to do their web testing. And they are fine tools. However, if you have like a RESTful web service that you need to test, or you have a website where JavaScript is optional, when you, for example, use progressive enhancement, then there are much simpler tools that you can use to do your job. So let's see some examples. So we're gonna test a simple Hello World resource. And how can we test it? So a first example, we instantiate our application, then we create embedded web server. We've already seen that, right? We pass the application as a first argument, then we use some configuration as a second argument. Then we create a request object. And please make sure that it's super easy to create request objects in your web library. You shouldn't need to mock HTTP requests for testing purposes. Then we're gonna use something like a simple HTTP client that comes with your web library. This is like a wget or curl equivalent in your Java language. And then you're gonna get a response from the application, and you can assert on the status code, for example. But now it's getting even more interesting. Another test. This time we instantiate our application again. We create a request object, but now we're gonna send this request directly to the application. Not many web libraries allow for that, but it's a very, very powerful mechanism. Now, just in case you haven't noticed, if you look at the client API and the server API, they're exactly the same. They are uniform. So now you can run your test against a client API or a server API, and those gonna be the same test. Very, very powerful mechanism. Not many web libraries get it right. We're actually getting really, really fast. It's only 20 minutes. I'm at number 8. So I'm gonna slow down. Dependencies. Be careful who you invite to your party. Okay, so let's say that you decided to throw a classpath party. And you invited some jars to your classpath party. You know all those guys. You invited them directly. But that's not the end of the story. Because those guys invited their friends to your classpath party. And you've seen some of those guys before, but not all of them. But that's not the end of the story. Because those jars' friends invited their own friends. And you have like a bazillion of jar guests at your classpath party now. Everyone is having fun, right? It's a huge party. Until it's like 3 AM in the morning, and one of the jars refuses to participate in your party. And you see this guy in the corner, and he's like vomiting with exceptions. The party is over. Now, your angry boss is calling you. He's like, what's going on in there? What are you gonna say? Are you gonna be like, no worries, boss, this is like a third-party jar. This is like a third-order transitive dependency. No, the moment you put something on your class path, it becomes your problem. Doesn't matter that it's a transitive dependency. I want to tell you about this library called Shaven Maven, which is a tiny dependency resolver for Java. And here's how it works. You basically tell Shaven Maven, hey, here's the list of files I want to have on my class path. This is my guest list for my class path party. And it understands like a Maven format, Amazon S3 format, HTTP format, a file format. So yeah, no XML, just a simple list of items that you want on your class path. But here's where it's getting really interesting. There's no transitive dependencies in here. And I know what you're thinking. Oh, it's crazy. No transitive dependencies? Well, I know it's so convenient to just declare a few dependencies and let your dependency resolver do its job, right? But maybe when you do that, you just defer the pain. So here's the thing. What if you could bring the pain forward and carefully select who you invite to your class path party on day one? I know it's not very Hello World app friendly, because when you want to quickly get up and running very quickly with a new library, you just want to declare one dependency and let your dependency resolver do what it's really good at. But maybe it's good for real production apps, where you want to be very, very careful who's going to live on your class path. I love this quote. When people don't pay the true cost of something, they tend to consume it inefficiently. Maybe if you had to carefully select what jars you add to your class path on day one, you'd think twice. Oh, this library has like 5 megabytes of dependencies. Do I really need it? And finally, I'll tell my younger self to really look under the hood. Because maybe this nice library with a nice Twitter Bootstrap front page is hiding some nastiness in the code. Maybe someone just put a lipstick on a pig and it looks nice in the documentation, but it's terrible code underneath. The truth is always in the code. If you're only gonna remember one thing from this talk, I want you to ask yourself this question. What are your values and principles that drive your technical decisions? I know my answers nowadays. I value simplicity over familiarity. I value quick feedback from extremely fast tools over lots of features, because extremely quick feedback gives me immediate connection to my work. I prefer explicit Java code over annotation, AOP, XML magic. I prefer single-purpose tools that can be composed together over those full-stack solutions that make me really productive for the first 2 weeks, but then I hit a wall. I prefer to go with the web, not against it. Those values and principles make me more effective than anything I've seen in the Java space or in software development space up to date. Of course, I'm biased. So you are. None of us have been on the same projects. None of us have worked with the same people. And of course, there are exceptions to the rule. And there are exceptions to those exceptions. So in your context, those things may not work. I'd like to calm my younger self down and tell him, it's okay to start with familiar. It's okay that you started with Struts 1, because it had this shiny book written about it. But it's even more important, after you gain some more experience, to stop and ask yourself a question. Why you're doing what you're doing? Why are you using this library? What problem is it solving for you? Is it also solving 20 other problems that you don't have? Can every single dependency on your class path justify its presence there? I'd like to thank all people who I stole those ideas from. None of those ideas are mine. They're all stolen, and I'm really proud of it. As Austin Kleon says, you are the sum of your influences, and you're only as good as the ideas that you surround yourself with. I think that our job as programmers is to look around and collect all those good ideas. But when we try to collect those good ideas, it's very tempting to just run with the herd, do what everyone else is doing. Thinking like a freak presents some downsides. You may occasionally say things that will make other people angry, because not everyone can separate their ego from the tools and practices that they use. But don't let it scare you. Find those outliers. Find those people who do things differently and learn from them. and you will be rewarded. Think like a freak. And that's my last message to my younger self. Thank you.